Okay, welcome to the lecture for chapter 12. We managed to get all the way through 11. That recording should be available through your Google Calendar. So looking at chapter 12, what we're going to be specifically looking at is the wrist joint. However, when we talk about the wrist, kind of have to talk about the hand, the elbow, even supination, pronation of the forearm. So now understand the wrist itself is an individual joint. And we can describe it as synovial, biaxial, because we have sagittal plane, frontal plane. It's a good combination of mobile and stable, not as mobile as the shoulder, more mobile than the elbow, not as stable as the elbow, but more stable than the shoulder. So it's a good combination. And the first thing that we have to look at is the radiocarpal joint, which would be C on this picture. So the radiocarpal joint is made up of the distal end of the radius, which is the longer of the two forearm bones in this diagram. It is also made up of the radial ulnar disc, and then distally is the scaphoid, lunate, and triquetrum. Adding on to that, in this picture, we see B, which represents the mid-carpal joint. So it separates the more distal carpals and the more proximal carpals. And yes, you will have to learn the names of the bones. I'll show you on the next slide how to do that. And then A represents the carpometacarpal joint, or CMC. It's often abbreviated. So it's the distal carpals along with the metacarpals. Looking at the notes, the intercarpal joint represents the joint that occurs between the carpal bones in each individual rows. So it's kind of a, instead of going across like A and B, it would be the other direction, 90 degrees perpendicular between those rows. Something to think about here. The wrist, flexion, extension, sagittal plane. Ulnar deviation, radial deviation is the frontal plane. No circumduction. If we look at this diagram, what we are looking at here is the individual carpals, radius, ulna. Again, the radius is represented by the longer of the two bones, and the radial ulnar disc. So if you look, the darker colored distal row, and then your proximal row is the lighter colored. Now here's a question for you. Are you looking at the anterior or posterior view of the hand? If you need to hit pause and think about it, go for it. The answer is the anterior surface of the hand. And how can I tell by just looking at this diagram? Well, if you look at letter C, that's the pisiform. You can only really see that from the anterior view. So that tells me I'm looking at the palm of the hand. Now there's an easy way to remember the order of the carpals in the hand. And that order goes so long top part, here comes the thumb. So long top part, here comes the thumb. Scaphoid, lunate, triquetrum, pisiform, hamate, capitate, trapezoid, trapezium. So long top part, here comes the thumb. Now, a couple things to think about is we are going to be, you have to look at both intrinsic and extrinsic hand muscles over the next couple of weeks. Wrist muscles. Wrist muscles are extrinsic, and what that means is the origin is either on the humerus and somewhere in the forearm. Intrinsic muscles mean that the muscles originate and insert within the hand. So right now we're going to focus on extrinsics. There's a couple of common things to think about here. Your common wrist flexor is on the medial epicondyle. Your common wrist extensor is on the lateral epicondyle, typically the more posterior aspect of it. So again, the common wrist flexor origin, medial epicondyle, common wrist extensor, lateral epicondyle. So now let's take a look at the joint structures, specifically the ligaments. So the wrist has a medial and lateral collateral ligament, except this time we call them the radial collateral ligament and ulnar collateral ligament. In the elbow we saw medial and lateral collateral ligaments. Essentially these function in a very similar way. So if we have a valgus push, it lengthens the radial collateral ligament. If we have a varus directional move, the ulnar collateral ligament is stretched. Next, we have to take a look at the palmar radiocarpal ligament. Now, this ligament is really divided into these three sections here. You can see that they originate on the radius and a little bit on the ulna. So the insertion point is the proximal row of the carpals, but it also includes the capitate of the distal row. So here's a question. Is the radiocarpal ligaments, are they going to limit wrist flexion or extension? Take a moment to think about it. If you need to pause the video, go for it. Okay, because these ligaments are on the anterior surface, they are going to limit wrist extension. So if you come into flexion, these are going to shorten. Whereas if you go into wrist extension, and if you do that, you can feel a little bit of that right through here, especially if you have the elbow straight. If you bend the elbow, I don't feel it quite as much. Next, we're going to talk about the dorsal radiocarpal ligaments. The publisher's images don't have a good representation of this, so take a look in your textbook on page 184, figure 12-6, and you can see how that ligament is constructed. And it attaches from posterior radius to the scaphoid, lunate, and triquetrum. So there's a little bit of a typo on my lecture notes. If you look, it says D, joint structures, ligaments, then it says palmar radiocarpal, dorsal carpal, dorsal radiocarpal, other ligaments. And then for some reason, I have those ligaments listed again. You only need to have them one time on your notes. Okay, so what you need to think about after reviewing this video and before a discussion on a Tuesday, which of these two ligaments, the palmar or dorsal, is stronger? And then ask yourself, what's the functional reason for that being stronger? So let's take a look at the joint capsule. So it's also called the radiocarpal joint, but don't let the name deceive you. The capsule incorporates all of this right here, including the ulna. And it is reinforced by the ligaments, the palmar, the dorsal, the ulnar collateral, radiocollateral ligaments. Going beyond the joint capsule itself, we also have to talk about the articular disc, which is represented by E. And the articular disc fills the gap right here at the ulna. Right, because remember, the wrist joint does not truly include the ulna. It is the radius that makes up the proximal bone of the wrist joint. The palmar aponeurosis, you'll also hear people refer to it as the palmar fascia. It is on the anterior surface or palm surface of the hand. And the function of the aponeurosis is protection and allows for muscle attachment. So the software that I'm using only allows a 15-minute recording, so this is going to be part 1 of 2. So I will finish up part 2. We'll cover the muscles and a few other things that I want to talk about.